So in this live stream, we'll be taking a casual look at Wondergraph's Cosmos, and so I've already gone ahead and set up I've gone ahead and got a repository here. What I'm going to do, actually, I'm going to fork this, so let me come out of this and let's go to the GitHub page. So Cosmos is an open source solution to building, maintaining and collaborating on GraphQL, federation at scale, the alternative to Apollo Studio and Graph OS. So I am fairly new to GraphQL. Very weird, just heard of it, if I'm honest with you, a few weeks ago. But apparently it's very popular. It's used by a lot of large companies, Facebook, etc. Massive companies. So it's not something I really touched upon that much. So I just want to dig into it and learn what I can learn. So let's start by forking this project. And then we'll create a code space to start digging around and see if we can just build something. Okay, so we'll just go back to the main page here. So this is the Cosmos GUI, and I think they're expecting you to already migrate. Like, obviously, it seems like a common thing is to migrate from Apollo. So there's kind of an assumption there that you're going to be doing that. Well, they've made it very clear. But I'm completely new, so we're going to go to this documentation here. So members, API groups, cache warmer, policies, linting rules, feature flags, okay, subgraphs, graphs. Okay, billing. Wow. So free, you get one user, one federated graph, up to 10 million requests per month. Discord community support. Launch, you get self-hosted router, 10 users, 2 federated graphs, 250 million requests per month, 14 days of data retention, email support. So this is like the managed solution, I believe, but apparently you can self-host, right? This is like, I'm not sure what this is for exactly. Anyway, let me see if I can just get something going. Okay. I got Claude installed. No. Let me just get Claude installed to give us a hand, maybe with some. So I want to interrogate the code base, so I think it's quite useful to have Claude code installed. So let me just do that. Okay, install. So I'm just having to install my API keys and things for Claude to give me a hand. So just doing it off screen. Okay, done. Okay, so what we'll do is get Claude to just do an initialization on the code base, because it's a code base I'm not really familiar with. So we can start asking some natural language questions about it. I think that might help us explore the project a bit more. While it's doing that, let's go for the README file. Let's make this a bit bigger. So WonderGraph Cosmos is a comprehensive lifecycle API management platform tailored for federated GraphQL. It encompasses everything from schema registry, composition checks, and analytics to metrics, tracing, and routing. Whether you're looking to deploy it 100% on-prem or prefer a managed service, Cosmos offers flexibility without vendor lock-in, all under the Apache 2.0 license. So get inside. Okay, so there's like an ebook thing. Yeah, I might read that later. There's 48 pages of it. Probably a good idea to have a look at that. Actually, maybe I can find the ebook. Don't have the ebook. Let's see. Got nothing yet. Hope the email's not broken. Could be. Just do a search main box quickly. And, maybe I'm just being impatient. No, that's not come through. So yeah, that's maybe a little bit of an issue. Can I just download it here? No. Would be good if I could just put the email address and download it straight away. Anyway, that might have been useful. GraphQL Federation drives business 55%. Respondents reported improved customer experiences, highlighting how GraphQL enhances user satisfaction. And how does it do that? 53% of respondents cited faster delivery, showcasing its impact on team efficiency. GraphQL Federation is the future of enterprises. By 2027, more than 60% of enterprises will use GraphQL in production, up from less than 30% in 2024. Okay. We can clearly see three focus areas in which GraphQL Federation users are going. Users want to implement more real-time use cases with subscriptions and solutions like EDFS, event-driven federation subscriptions. Okay. Okay, let's close that one. So, it's asking me permissions for something. Should have just do. Why federated graph? GraphQL empowers organizations to break down their GraphQL schema into multiple smaller, manageable schemas, each maintained by different teams or services. These individual schemas are then combined into a single unified graph, ensuring that all teams have consistent access to the data they need. In today's data-driven world, where information is often referred to as the new oil, don't think I'll refer to it like that, but okay. Building a unified API that can be consumed by both internal and external teams is more crucial than ever. Yeah, I'd agree with that. Not all companies start with a federated architecture. Cosmos supports both monolithic and federated architectures. Let's get started with WonderGraph Cosmos. For these steps, clone the repo, which we've done. Choose your example. Select the example that best fits your role. And try Cosmos now and follow the instructions. Examples, okay. Okay, full Cosmos Docker, Helm. Right, this full Docker, this example demonstrates how to run the entire Cosmo platform locally on Docker Compose. Okay. I don't know if I'm going to be able to do this in code spaces. Might have to do it locally or no, I'm not going to. I'll have to do this probably on Docker desktop. Yeah. Okay. just going to reclone this on my local. See if I can get this working. I'm just curious what the limitations of code spaces is. Limitations. Okay, I might be able to run it. Curious. Let's try it anyway. Doesn't work, it doesn't work, then we've learnt something, haven't we? Right, so to set this up, we can just do start shell. Open another terminal. That code run in the background. Okay, it's doing something. Okay, S3 access key. Oh, key cloak. Okay. I know key cloak. GraphQL metrics. Kafka. That's OTL connector, Postgres, ClickHouse, migration, seed. What's seed? I've heard of seed before. Oops. ClickHouse migration. Not sure if this is what it's talking about. Set up lab environments using Docker Compose and many other seed labs. You need more than 10 containers, create them one by one, setting up the network becomes tedious. Docker provides a tool called Compose. Yeah, we know that. Okay, is that what this is doing? Don't know. I'll come back here. Where was we? It's still running. It's Claude finished. Okay. Let's ask. What can we do with Cosmos? It's a bit of a basic question. It's probably a bit too broad, actually. Let's see. Okay, so according to Claude, and on the analysis of Cosmos codebase, here's what you can do with Cosmos. Build and manage distributed graph QL APIs across multiple teams, break down monolithic GraphQL schemas, manage intermanageable subgraphs, Propose multiple GraphQL services. Okay, I'm just gonna ask a real basic question. Layman's terms. What is GraphQL? Where was we? Right. Alright, in simple terms, imagine you're at a restaurant, traditional APIs REST. The waiter brings you a fixed meal combo. Want just a burger without fries? Too bad, you get the whole combo whether you want it or not. GraphQL, you get to order exactly what you want. Just the burger, sure. Burger with extra pickles but no tomato, no problem. You ask for exactly what you need, nothing more, nothing less. Okay. Key concepts. It's query language for APIs, a way to ask for data from a server in a very specific, flexible way. So you request exactly what you need, user name, email, post title. This says give me the user's name, email, and just title of the post. Benefits, so no overfetching, you don't download unnecessary data. And no underfetching, get everything in one request instead of multiple. It's predictable, you know exactly what data you'll receive. Flexible, a front end can evolve without back end changes. In the real world, instead of making 3 separate requests to a user's profile, their posts and their friends list, GraphQL lets you get all of this in a single efficient request where you specify exactly which fields you want from each. Think of it as a smart assistant that can fetch exactly what you ask for from multiple sources, package it neatly and hand it to you in one go. Okay. That's what I really like about Claude Code, actually, and having this right in the terminal. You can just ask questions like that, break things down, and make things a bit more understandable. So when learning something new, it's really, really useful, in my opinion. Okay, so that is finished. So composition errors. Okay, so I've got graph token. Well, it's not stored in a safe place, is it? Because everyone can see it. Okay. So use a token to authenticate against the control plane from the routers. Start the subgraphs and the router. Okay. It's done lots of things. Right. Oh, it's still building stuff. What's it doing? Still doing things here. URL. Cosmos example. Already did that, I don't want to do that again. So where is the URL? That's what I want to know. So how do I get to the front end? Huh. Does seem to do something. Blank though. Okay. Is that because this is still running? It's probably because it's still running. Might be still building things. But let's do something. No. Use. Let's get the URL. Playwright. Playwright or playwright? I don't know. Use playwright to test the site and fix as needed. Just going to dangerously skip permissions because I don't want to babysit it. Yep, and run code spaces. It's not end of the world if it goes haywire. Right, so yeah, what was I going to do? Is this working yet? No. Right, use playwright to test endpoint and fix as needed. Okay, let's see what we get. I'm just going to look at the logs here. Composition errors. I think this obviously is why it's not working. I might chuck that into Claude. Let's chuck this into Claude as well. Give some more context. Probably will help. More context. In the build. while it's doing that, I'm going to go back to the README file. So, okay, so choose the project best suits your role and use case. Platform engineer. So, example demonstrate how to use it. Run the entire platform on Kubernetes. The official Helm chart. Use Minikube. Okay. Okay, local development to contribute to the repo. Any questions? Contact sales. Blog post focus on technical aspects of Cosmo. Okay. Let's have a look at one of these. Yeah, let's have a look at that one. Supergraph kickoff, scaling your federated graph QL for the Super Bowl. One problem we keep seeing among our customers is the need to prepare the APIs for big events. Yep, makes sense. Whether it's Super Bowl, Black Friday, or big product launch, these can put a lot of stress on your API. If you're using a federated GraphQL, the most critical part of your infrastructure is the GraphQL gateway, typically called a router, that sits in front of your federated services. The router must be able to handle the increased load and traffic spikes that come with these events. In this post, we'll dive into the engineering behind reading up for one of our customers' Supergraph for the big game. Hiring, okay. You'll learn how we've implemented a heuristics-based query planning cache warm-up strategy to avoid cold starts. Okay. And scale the route to handle 100,000 RPS and beyond. Here's what we've achieved. The graph below shows the router's max query planning time. Without the cache warm-up strategy, the max planning time would fluctuate between 8 and 10 seconds. Okay, so with the cache warm-up strategy in place, the max query planning time is consistently below 1 second. So how does the cache work then? challenge: what are the biggest bottlenecks in a federated GraphQL API-driven traffic spikes? The post primarily focuses on the router. For completeness, let's quickly discuss all bottlenecks in Supergraph. Network: the network between the clients and the router, and between the router and the federated services. The router itself. We'll dive deeper into that next section. Yep. Subgraph services, subgraphs themselves, including the dependencies. So what's a subgraph? Oh, service. Why is it called a subgraph? Okay. Databases that the subgraphs are querying. It's important to test network in terms of thoroughness, in terms of throughput and latency. It's very likely that you're using proxies or load balancers in front of your router, or maybe even between the router and subgraphs. In any case, it's crucial to properly configure connection pooling, timeouts, retries, and keep alive settings. Okay. There's high likelihood you can't just depend on the default settings, as they might limit other parts of your infrastructure. So the subgraph services, here we go. The subgraphs themselves are typically the easiest to scale, although there are also some common pitfalls. For example, it's important that you're using the data loader pattern to batch load entities and avoid n+1 situations. Also make sure your subgraphs are horizontally scalable and that you're not hitting any rate limits on your dependencies. If you're calling external services, it's important to have a proper rate limiting strategy within your subgraph to avoid cascading failures. Make sure to gracefully handle errors and retries in such a scenario to avoid thundering herd problems. Okay, technical term. In addition to the circuit breaker pattern, can be a useful tool to prevent cascading failures throughout your entire supergraph. Another issue was synchron. Where was it? So lost. Where was I? Observing supergraph caches. I've lost my place. Where was I? Oh, right, yeah. Just getting started. Right, optimization, subgraph caching, +1 situations, no. Benchmarking, obvious trap. Okay, so another essential part of your scaling your subgraph is how you're monitoring them and what metrics you're using to determine if the autoscaler should scale them up or down. Benchmarking your subgraphs can reveal their CPU and memory usage under different loads, which can help you determine the right scaling strategy. Scaling up or down can take some time, so you need to take into consideration the lag between the decision to scale and actual scaling. Scaling up too early can lead to unnecessary costs, while scaling too late can lead to degraded performance. So, Goldilocks territory. Another obvious strategy to improve scalability of your subgraph is to introduce caching. This can be done at different levels, from in-memory caching within the subgraph to a shared cache like Redis, entity-based caching at the router layer, or HTTP-based caching at the edge layer. And finally, normalized caching at the client layer. Just keep in mind that caching is not free and introduces a new set of challenges like cache invalidation, cache inconsistency, or cache synchronization issues between different layers. My general advice is not to blindly optimize, but to measure, monitor, and benchmark your whole supergraph architecture to identify the actual bottlenecks. Oftentimes the best optimization is not to optimize at all, so just leave it as it is. Worst case, you're de-optimizing while you're thinking about doing the right thing. Cosmo Router gives you extensive capability to monitor and observe your supergraph with OpenTelemetry (OTel). Okay. Support metrics and traces, access log, and Prometheus metrics. You can easily identify bottlenecks to optimize your supergraph precisely where it's needed. Database. Finally, once you've sorted out the network and subgraph bottlenecks, it's typically the database that becomes the bottleneck. While a NoSQL database might be able to handle the increased load, a Postgres or MySQL database can get you very far with proper indexing and query optimization. Oftentimes it's not the database itself that's the bottleneck, but the way you're using it from your subgraphs. Alright, we're ready for the Super Bowl, aren't we? Not quite. Let's dive into the router. Engineering behind scaling a GraphQL Federation router to 100k RPS and beyond. What is RPS? Let's ask God. Oh, something's broken. Didn't like it. What is RPS? Rate per second? Request per second. Yeah, okay. RPS. First step is to tokenize incoming requests. Okay, query normalization and validation. Normalization. It's the process of converting AST into a normalized form. Do love an acronym. AST. What is AST? What is AST? Asynchronous something. Abstract syntax tree. Abstract syntax tree. A tree representation of the syntax structure of source code. Each node in the tree represents construct in the programming language like expression statement or declarations. AST is commonly used by compilers and interpreters. How does this relate to Cosmos? back to that. Most important step is to ensure high cache hit ratio on the query planner cache. We wrote about this topic in detail in a post, how normalization affects query plan caching. So validation is the process of ensuring that the query is semantically correct. This includes checking if the query is well formed, if the requested fields are available in the schema, if the arguments are of the correct type, and if the query is allowed to be executed by the current user. Both normalization and validation are CPU bound operations. It is important to understand that you'd want to optimize CPU bound operations to leverage the full potential of your CPU cores. It's hard. I am going to get through this. At the same time, you also don't want to spawn too many threads or processes, as this can lead to contention and context switching overhead. As a solution, Cosmo Router allows you to limit the total number of concurrent parsing, normalization and validation operations. This way you can adjust the number of threads, go routines, to the number of CPU cores available. Okay. Query planning. Query planning is the process of determining which subgraphs need to be queried to fulfill the incoming requests. It's another CPU bound operation and is probably the most complex part of the router. When I say router, what route are they referring to? Anyway, I'll get to that. Query planning is hard to parallelize, so it's typically a sequential operation that scales with the complexity of the query. If you're querying deeply nested abstracted fields, user interface across multiple subgraphs, the query planner needs to do a lot of work to figure out the optimal query plan. As optimization, Cosmo Router parallelizes some parts of the query planning process while relying heavily on indexes and caches to speed up the process. As a result, we're able to plan the most queries in less than 1 millisecond. However, there are outliers that can take up to a few milliseconds or even seconds to plan. We looked at the competition and found that alternative implementations can take up to 10 times longer to plan the same query, or even fail to plan it at all. We're continuously improving the query planner to make it even faster and more efficient, but there are physical limits to how fast we can make it. In addition, we're also balancing the trade-off between planning, time and code complexity. At the end of the day, our goal is to provide not just a fast query planner, but also a reliable and maintainable one. Experts in the field of query planning will probably agree that a lack of strong federation query planning specification leaves too much room for interpretation. As a result, there are rare edge cases that require a query planner to do lots of extra work. Oh my god, this is boring. I'm sorry, I'm not a query planner, I'm a DevOps guy. As a result, there are rare edge cases that require a query planner. I've already read that. Luckily, engineers from different companies working together in the composite schema working group. Seriously? What the hell is this? It's like some secret organization I don't know about. The composite schemas working group It is a secret committee, isn't it? It's a subcommittee. Okay. GraphQL Conf. I never knew there was such a thing. Okay. In San Francisco. When's the next meeting? Is this a club that I can join? I don't know. Don't talk too much. I can relate to that. I've been talking too much right now. Yeah, I don't think I'll be joining that group too quickly. Some guys, clearly these guys know a lot more about it than I do. Okay. I'll be going deeper than I've got time for today. Query execution, data loader, okay, data loader, data loader algorithm. It's proven to be very efficient at loading data concurrently. We need to find an efficient way to merge results from different subgraphs as a solution. Developed Act JSON. This library allows us to efficiently merge large nested JSON objects at the AST level instead of moving data around in memory and converting it back and forth between JSON and Go structs. We've taken the approach to transform all JSON strings into AST, merge them at the AST level and serialize the file back to JSON one single at a time instead of moving around bytes or strings all the time. We're only moving around the pointers to AST nodes. AST nodes, okay, which is much more efficient in terms of memory and CPU usage. If you'd like to learn more about this, take a look at the introductory post. That's probably where I should have started, maybe. But let's move on. I'm going to jump to the conclusion. In the post, we've discovered the most important parts of scaling federated GraphQL router 100k RPS and beyond, from network subgraph databases to router. I identify query planning as one of the most influential parts when it comes to performance. So query planning is really important. That's kind of what I'm learning about this. With the introduction of heuristics-based cache warm-up strategy, we've eliminated cold starts and put the subgraph router on autopilot. It got lost somewhere in the middle of the post. If got lost somewhere in the middle, is the cache warm-up documentation, in case you'd like to remember that feature. Okay, so that sounds quite important. Before reading this blog post, you might not have been aware that cold starts in your supergraph router and how they can impact your supergraph performance. I don't even know what supergraph is at the moment, so I've still got to figure that out. What is a supergraph router? Right. In Cosmo, AST is crucial. The platform uses ASTs to parse graph queries into tree structures, compose federated schemas by merging multiple subgraphs. ASTs plan query execution. Okay. Oh yeah. What is code space is running out of disk space. It doesn't look good. I don't think it's going to work on code spaces, if I'm honest. I don't think it wasn't really designed for code spaces, I'm sure. So I think probably obviously the easiest thing to do would be to use the CLI tools to set up the graph on here. So I think I've got to do a bit more reading on this because I don't know enough about it yet. I think I'm going to have to start wrapping this up. I just want to know what supergraph routers are. I mean, I know what a router is, but a supergraph router. So a supergraph router is the thing responsible for routing the queries, right? From what I understand. Why as is our thing broken still? Yes, it's broken. This is still running, probably taking all my disk space. I'm going to cancel this. I think what I'll have to do is revisit this at some point to actually maybe put it on my local Docker desktop, or I might look into the Helm chart example next time. Probably not this week, maybe some point in the future. Yeah, so I mean that's interesting. I've learned a few things. I've learned a bit more about what GraphQL is. I would like to actually dig a little bit more deeper into this. Seems like this is being used by a lot of people, a lot of big organizations for doing things at massive scale. So it's really quite interesting, if I'm honest with you. But probably not something a lot of engineering teams actually need, or maybe I'm not seeing a need for it. This is really when you're working at a massive scale. I think that's what we're learning here, right? And so that's the solution, and that's why actually it's quite expensive. If we look at the pricing, you're doing a lot of 2 federated graphs, 5 federated graphs. So I'm curious who uses this kind of stuff. Customers. So customers, eBay. Yeah, see what I mean? These are massive companies. Absolutely massive. Yeah. Interesting. interesting. Let me get on the Discord, and I'm gonna have a little poke around here. Yeah, I'm curious to dig deeper, but it's having the time to do it right now. Yeah, it's not going to work on code spaces. It's good for. I might dig into a bit more of Claude. But I think, yeah, the next thing I need to do really is get this working on a decent workstation with enough RAM and stuff to play around with it. You know, this. Just wonder if I can ask. Can we? Plan a project to learn about using Cosmos. We've already got the examples, so but it's yeah, I need to look into all the areas, but I think, yeah, best thing to do right now is we'll wrap this up here, and I'm going to at some other point, probably later in the week or next week, I'll revisit this and, yeah, dig a little bit more deeper into the actual implementation. So there's a lot here to look into, a lot. So yeah, this is what Claude is suggesting. So I'll set up a local development environment. Installed environment. So this will be our plan then. Not today. But yeah, so phase 1, foundation, high priority environment setup, install pre-access, Docker, Go, make infrastructure. Yeah, that's kind of what the examples I think are meant to do. We'll go through these. We're looking more into the router. I mean, we've touched upon that through the articles. I'd like to dig more into what this router thing is. Control plane, studio, GraphQL metrics. Learn, connect RPC communication patterns. Understand federation and monolithic GraphQL. Build simple federation. Create 2 to 3 example subgraphs, users, and product orders. Practice schema definition with federation directives. Deploy subgraphs, connect to router. Yeah. Learn key directives. Practice entity resolution. Use Studio UI for schema management and router deep dive. Explore the query planning and execution. Understand subgraph and configuration. Test complex federated queries. Then phase 3, observability, set up ClickHouse for metrics, configure tracing and monitoring, use GraphQL metrics service. Then production feature, implement feature flags, test schema contracts, and configure authentication and security. So I think what would be cool actually is do something like this to dig more deeper into the whole implementation of it. Actually go through these examples, maybe get Claude to help us kind of speed up our learning on this. So yeah, I think that the next session we'll do that. we'll kind of go through a learning. I'll come up with a bit more of a project plan, but I quite like this idea, the learning plan. And then yeah, we'll go from there. So I'm going to wrap this up now. I hope, I don't know, I've learned something. I haven't really come across GraphQL much before, so yeah, this is really just me meandering around the Cosmos product, learning a bit more about it, what it does, what its uses are. So we've learnt that it's used by really big companies that need to serve, when basically their APIs are getting hammered. So big events, you need to be able to route those requests and balance those requests. So you've got the scaling solution. So yeah, it's like a whole kind of enterprise level API. API management system, I guess that's what you could call it, isn't it? But yeah, so pretty cool. Very complex. There's a lot to it. Highly technical. And it seemed like I've only just scratched the surface here a little bit, but yeah, very interesting. So we'll leave it there, and I'll come back probably in a week or two, maybe, to dig more into the. I'll come up with more of a learning plan for this and dig more into it then. Yeah, so it's a little bit of a detour from some of my other stuff, but it's something that came across my desk and something I needed to look into. So yeah, I found it useful, and I hope you did too. Good night.